Think about all the activity happening on Amazon every single second. I mean,
Mm,
the searches, the clicks, the buying, the ads you see everywhere. It's just this incredibly complex ecosystem, right?
absolutely.
And, well, at the heart of it all is data, just mountains and mountains of it. How does Amazon even keep track of it all, especially, the stuff that happened weeks or even months ago?
Yeah.
How does it use that to figure out which ads to show you or where products should rank?
Welcome to the deep dive. Today, we're sort of pulling back the curtain on this hidden world of data collection and storage, the stuff that powers Amazon's advertising system, and specifically its ranking memory.
Yeah, that's right.
We're going to try and understand exactly how Amazon gathers, how it keeps, and crucially, how it uses all that historical information that influences, ad placement and product visibility.
And our map for this journey, it's based on a pretty deep research document. It really explores these comprehensive questions about Amazon PPC ranking memory, gives us a real technical and strategic look under the hood.
Under the hood, yeah. It reveals some, frankly, incredible details about the systems involved. So our mission for this deep dive is, well, it's clear. We're going to uncover everything this document tells us specifically about the data side. That's Amazon's data collection, its storage, and the massive systems that manage it all.
Okay.
We'll take the complex technical bits and, try to make them understandable, show you the actual foundation of that ranking memory.
All right, let's get started then. To understand how Amazon remembers performance, we first have to know what information it's even collecting. Like, what are we talking about here? When we talk Amazon PTC, ranking memory, what specific types of data are actually flowing into this system?
Okay, so it really starts with the fundamentals.
Yeah.
The basics of pay-per-click advertising. The document confirms, yeah, they collect the core metrics. That's the bids advertisers are setting on keywords.
Right.
The keywords themselves, the clicks the ads get, the impressions, when an ad is shown to a shopper. And crucially, the conversions, the actual sales that happen after someone clicks an ad. Those are the building blocks. And then from these basic pieces, they calculate the KPIs, the key performance indicators. You've probably heard of these.
Yeah, CTR, ACOS.
Exactly. Click-through rate, CTR, what percentage of impressions actually got a click, advertising cost of sales, ACOS, your ad spend, versus the sales from those ads, and return on ad spend, ROAS, just the revenue divided by the ad spend.
Got it.
These numbers, they give you that real-time feedback on how the ads are doing. It's compared to old-school ads like print or TV. The data is just incredibly granular and available almost instantly.
Okay, clicks, sales, bids. That seems straightforward enough. But reading the document, it really feels like the A10 algorithm, the system's memory. It goes way, way beyond just those ad metrics now, doesn't it?
Oh, absolutely. Yeah, the system's evolved dramatically. And the document, it details this much broader landscape of data signals that all feed into this ranking memory. It's not just about the ad click anymore. So a massive category is what they call customer behavioral signals. This isn't just about clicking an ad, it's how shoppers behave after they interact, or sometimes even just when they're browsing.
Okay, like what?
Well, things like session duration,
Yeah.
how long a user actually spends looking at a product page.
Yeah,
Longer time suggests more interest.
makes sense.
Then there's repeat purchase rate. How often does a customer buy the same product again? That's a huge signal for product quality and satisfaction, and it feeds into those longer-term performance signals.
Right, loyalty.
Exactly. Cart addition rate, just how often a product gets added to the cart. Even if they don't buy it right away, it signals strong intent. Device type is tracked. They analyze mobile versus desktop behavior separately because, well, people shop differently on their phones versus computers.
Sure.
They track time of day patterns, figuring out when users are most active searching and buying certain things. And they analyze individual user purchase history. Now, this isn't directly tied to every ad ranking for every search, but it definitely informs personalization and helps understand a product's overall appeal.
Okay.
And reviews are big too. Review velocity, how fast is a product getting new reviews, and review sentiment, are they positive or negative? That directly hits customer trust and how relevant the product seems. And beyond just behavior, there's creative and content data. The document highlights how Amazon uses information right from the product listing itself.
You mean like the text and images?
Yeah, precisely. Things like image alt text, the text description behind an image, and video metadata. And get this, the source specifically says that since 2023, they've been using BERT models, that's advanced AI, for language.
Right, language models.
To process this data, to better understand what's in the visuals. This helps match products to searches much better. They also track the performance of different ad creative versions or different listing images using tools like Dynamic Creative Optimization plus AIR or DCO plus CARE. And they process literally billions of product attributes, feature size, color, material, using something called deep KNN algorithms, K nearest neighbors. It helps them deeply understand what a product is to match it to really complex searches.
Okay, so the listing itself is feeding the memory. What else?
Seller and account health data. This is another piece. It reflects the seller's reliability, which kind of implicitly affects how much the algorithm trusts ranking the seller's products.
Ah, okay. Like your seller rating.
Sort of, yeah.
Yeah.
The order defect rate, ODR, that measures issues like negative feedback or chargebacks, it's tracked account-wide. And the doc notes sellers keeping ODR under 1%. They get specific visibility advantages.
1%. Okay.
There's also the account health rating, AHR, that score from 0 to 1,000. Sellers hitting 750 or above, they receive ranking boosts according to the source.
That's 750. Got it.
And inventory stability. This is critical. The system tracks how often you run out of stock. Listings with low stockout frequency, defined as 5% or less, they hold on to their ranking momentum much better than products that are always out of stock. Stockouts definitely penalize ranking, and this data is core to that.
Right. You can't sell what you don't have.
Exactly. Now, here's a really interesting one. External traffic signals. This is data about traffic coming to Amazon from outside Amazon.
Like from Facebook or a blog post?
Precisely. Think links from TikTok, Instagram, influencer campaigns. Amazon uses tools like Amazon Attribution to specifically track clicks and conversions that happen on Amazon because someone clicked one of those external links.
Okay.
But, and this is really important, the document clarifies this: Amazon does not directly pull in your sales history from, say, your own Shopify site, but it absolutely tracks the traffic and the resulting Amazon purchases that originated from that external link. And that performance data, it feeds the ranking memory.
That's a key distinction. So external traffic driving sales on Amazon counts.
Yes, very much so. And of course, underpinning it all is search and keyword data. They analyze search query reports the exact words customers type. They examine over 200 linguistic features in the product listings themselves. This gets pretty detailed, analyzing keyword density, for instance. The document suggests 3 to 5 core keywords in the title is optimal.
Okay.
The terms sellers put in the back-end search terms field, the whole structure of the content. They can even use search data to help identify competitors' keywords, sometimes revealed through tools like Cerebro. And with voice search booming, they track natural language phrases, question-based keywords, even localized pronunciation variants to match Alexa commands to products.
Wow, even pronunciation.
Yeah. And finally, there's brand-specific data like overall brand search volume and multi-product engagement, which is how users interact with several products from one brand in a single session. And audience data, things like audience quality score and view-through attribution, which tracks if someone saw your ad elsewhere online, didn't click, but later searched for and bought your product on Amazon.
Okay, wow, that is just a staggering amount and variety of data. It's far beyond just clicks and sales. It's behavior, it's content, seller reliability, even where the customer clicked from. It's like Amazon's trying to collect every conceivable signal about a product's performance and a seller's trustworthiness.
Pretty much, yeah. They're building a very detailed picture.
So with all this data pouring in constantly, how long does Amazon actually keep it? Or maybe more importantly for us, how long does the ranking algorithm remember its influence? How long does this memory last?
Right, and this is a key point the document clarifies, because it's often where people get mixed up. There's a really crucial distinction between how long the raw data is available to you, the seller, in reports, and how long its impact is remembered by the algorithm for ranking purposes.
Oh, okay. Two different things.
Exactly. So raw data retention. This is about how long you can actually go into Seller Central or use the Amazon Ads API to pull detailed performance reports. And this has specific, relatively short limits. For sponsored products data through the API, it's 95 days. The document notes this actually increased from 60 days previously.
95 days, sir.
For sponsored brands data, it's 60 days. And for sponsored display, it's 65 days.
65, okay.
Now, basic aggregate metrics in the console, like your total sales over the last year or something, might stick around longer. But the really granular reports, the ones you need for deep analysis like search term reports, those generally expire after that 60 to 90-day window. You just can't access the raw daily numbers beyond that point through the standard tools.
Right, so the detailed reports have a shelf life.
Correct. But now, algorithmic ranking memory. This is different. This is about how long the signal from that historical performance data actually affects where your ad or product ranks. And the document states this influence is retained by the A10 algorithm for much longer, up to 180 days.
6 months.
Yeah, roughly 6 months. So even if you can't pull a report showing the raw click data from, say, day 150, the algorithm still remembers that performance and factors it into its calculations today. The 180-day window, that's the real ranking memory we're talking about.
Okay, that's a huge difference. So how does that memory work? Does old data count just as much as recent data?
No, and that's the clever part. The document explains it uses a concept called a power law decay model.
Power law decay, okay.
It basically means recent performance is weighted much more heavily. The influence of older data decreases or decays exponentially over time. Think of it like your own memories. The things that happened yesterday are much clearer and stronger than things from 5 months ago.
Right, makes sense.
Specifically, the document quantifies this. It says the last 30 days of performance data account for roughly 60% of the weighting the algorithm gives to historical performance when making ad ranking decisions.
60% just from the last month.
Exactly. The data from days 31 through 180. That collectively contributes the remaining 40%. But its influence decays week by week. The document puts that decay rate typically between 8% and 12% per week. It can vary a bit by product category, maybe faster decay, like 12% for fast-moving electronics, and slower, maybe 5% for things like home goods.
Okay, so it fades but doesn't disappear entirely for 6 months.
Precisely. And this weighting of recent versus older data, it also differs slightly depending on the specific metric being looked at.
Oh, really? Like how?
Well, for click-through rate, CPR, the weighting is about 65% based on the recent 30 days. For conversion rate, CVR, it's a bit higher, around 70% recent. Sales velocity is weighted roughly 75% recent. And that external traffic data we talked about, that has the strongest recency bias. About 80% of its influence comes from recent performance.
Wow, 80% for external traffic. That really shows how important driving recent sales from outside Amazon is.
It really does. And this long-term decaying memory, it's also what enables this concept the document calls evergreen status.
Evergreen stat.
Yeah. It explains that products that show consistent, strong performance specifically, maintaining a CTR of 0.8% or higher and a conversion rate of 12% or higher for 90 days or more, they achieve this status.
Okay, 0.8 CTR, 12% CVR for 3 months.
Right. And getting that status basically locks in algorithmic preference. It helps preserve your visibility and makes you less dependent on super high bids for a longer time. The document even notes that products with this status can keep 60% to 80% of their visibility, even if they pause bids temporarily for up to 14 days. It's a direct result of that long-term memory rewarding consistency.
That's a huge benefit, a reward for steady performance.
Definitely. And just briefly, the document mentions a workaround for sellers who need that raw data longer than Amazon keeps it in the console. You can use API integration with third-party tools. Think Celex, Helium 10, tools like that. They can automatically download your campaign data every day and store it for you. So you can build your own complete history for analysis, even if the Amazon reports only show the last, say, 90 days. While Amazon does have lifetime reports in Campaign Manager, they're just aggregate monthly summaries. They don't have the daily detail you need for real deep dives.
Okay, so the takeaway is raw reports vanish after 60, 95 days, but the algorithm's memory, its impact, lasts up to 180 days, with recent stuff mattering most thanks to that power law decay. Got it.
You got it.
Now, managing all of that clicks, sales, behavior, inventory, reviews, external links for millions of products, millions of customers, keeping 6 months of weighted memory, that requires just an insane amount of technical horsepower, right?
Yeah.
How does Amazon actually store and process this mountain of data? What does that engine look like?
Yeah, this is where the scale just gets truly, truly staggering. The document gives us some incredible insights here. First, just to graph the data volume. The estimate is that each product generates roughly 1 to 2 kilobytes of these performance metrics every single day.
1 to 2 KB per product per day.
Yep. Now multiply that by Amazon's catalog estimated around 100 million products. That comes out to 100 to 200 gigabytes of new performance data daily.
Wow.
Over a year, that's 36 to 73 terabytes. And storing 180 days worth of this historical data for the ranking memory, that requires a massive 18 to 36 petabytes of active storage capacity.
Petabytes. That's thousands of terabytes. Just incredible.
It's enormous. And to handle it, they rely heavily on their own cloud, AWS, naturally. For storage solutions, they use things like distributed databases, specifically mentioning Amazon DynamoDB and Amazon S3. Think of these as databases spread across tons of machines built for scale. DynamoDB handles real-time stuff, fast lookups, while S3 is like this giant, infinitely scalable digital warehouse for the bulk historical data. They also use specialized columnar formats like Parquet and ORC. Instead of storing data like a spreadsheet, row by row, these store it column by column. This is way more efficient for the kind of analysis they need to do, and it compresses incredibly well. The doc says these formats achieve 75% to 80% compression, which leads to huge storage cost savings estimated around 60%.
75 to 80% smaller storage, that's huge at petabyte scale.
Absolutely essential. Then there's real-time processing. Ad auctions happen in milliseconds, right? So the system has to handle insane traffic up to 500 million requests per second during something like Prime Day.
500 million per second.
Yeah, and the ranking decision for which ads to show, that has to happen within a super tight 120 millisecond latency budget, faster than you can blink.
Incredible speed.
In-memory caching is key. They use solutions like Redis or Elasticache. These keep the most frequently needed data, like those crucial 30-day weighted ranking memory metrics, right in the computer's fastest memory. Okay. This allows retrieval in just 5 to 10 milliseconds. They also have streaming data pipelines using Amylon Kinesis, which the document says processes over 1 trillion daily events, clicks, conversions, page views in real time, constantly updating those metrics across the system.
1 trillion events a day, just feeding the beast.
Constantly. And machine learning, ML, is the brain making sense of it all. For model training, they train over 100 different ML models every day. They use petabyte-scale datasets to train models for ranking, ad relevance, everything. This happens on Amazon SageMaker using distributed training, spreading the work across over 1,000 GPUs, graphics processing units. This setup apparently cuts training time by 60% compared to traditional methods and saves about $2 million per month in compute costs.
$2 million a month saved just on training faster. Wow.
And for inference, that's using the trained models to score ads in real time. Remember that 120 millisecond window? They need to score thousands of potential ads for every search query in that time. So they deploy specialized hardware, AWS Inferentia chips. These are custom built for ML inference and can handle over 100,000 inferences per second at about 110th the cost of using regular GPUs for that job.
Specialized chips just for scoring ads faster and cheaper. Okay.
To manage the sheer load, distributed computing is fundamental. Data is broken up using sharding. Think of it like dividing a giant phone book into smaller neighborhood books. The doc mentions products are sharded based on their ASIN hash, that unique ID, across over 10,000 DynamoDB shards. This spreads the load. Using multiple regional data centers also cuts latency. And for calculating those 30-day averages for ranking memory, they use batch processing via Amazon EMR, which crunches over 500 billion records daily.
10,000 database shards, 500 billion records processed daily. The numbers are just mind-bending.
They really are. And the underlying network and scaling has to match. They use AWS Global Accelerator, routing traffic through over 100 edge locations worldwide for low latency. Multi-AZ deployments mean data and services are copied across at least 3 separate physical data centers within a region. This gives incredible reliability. The document cites 11 nines, 99.999999999% durability for data.
11 nines. So basically the data is never lost.
Pretty much negligible risk. And EC2 auto-scaling lets them flex their computing power. They can scale from a baseline of 10,000 instances up to 500,000 instances for huge events like Prime Day, often using lower-cost spot instances for about 70% cost savings.
Scaling up 50x on demand? Wild.
Finally, cost optimization is woven throughout. They use tiered storage. That hot data the last 30 days needed constantly for the Decay model. That lives on fast, more expensive NVMe SDs, costing around 0.12 cents per GB per month. But the colder historical data, days 31 to 180, that gets moved to cheaper archive storage like S3 Glacier, costing only 0.000414 cents per GB per month. This tiered approach alone saves about $8 million per year for storing 10 petabytes. They also optimize how they query the data, using services like Athena and Presto, cutting query costs by about 40%.
Wow. Okay, that level of technical detail, the sheer scale, it's hard to even wrap your head around. It's definitely not just storing numbers. It's this massive, real-time, hyper-optimized, constantly churning engine built on a literal mountain of data.
That's a good way to put it.
So with all that complexity, all that data flowing, how does Amazon make absolutely sure the data is accurate? How do they prevent corruption or, manipulation? Because bad data could completely wreck that 180-day ranking memory, couldn't it?
Oh, absolutely. Data integrity is foundational. If the algorithm can't trust the data it's using, the whole system falls apart. So Amazon uses this multi-layered framework to protect it.
Okay, layers of protection, like what?
First off, cryptographic integrity verification. They use checksum algorithms, CRC64 NVMe, SHA-256, SHA-1 are mentioned. Think of a checksum like a unique digital fingerprint for data.
Like a file hash.
Exactly. They calculate this fingerprint before uploading data, check it after it's stored, and they do periodic rechecks to catch any errors or tampering. They also use append-only S3 buckets with versioning. This means data objects can't be deleted or overwritten, only new versions added. And every update gets logged with the SHA-256 hash, creating this immutable audit trail. The document describes it as almost like a private blockchain for data history.
So you can always trace changes back.
Precisely. Then you have redundancy and repair systems. Data is stored redundantly, as we said, across at least 3 AWS availability zones, separate physical locations. They use quorum consistency checks when reading data, meaning they need confirmation from multiple copies, which guarantees that 11.9's durability. And they use erasure coding, like the Reed-Solomon algorithm.
So erasure coding.
Yeah, it's a technique where they split data objects into multiple parts. The example given is 32 data parts and 14 parity parts. If some of those parts get corrupted, the system could automatically rebuild the corrupted bits using the remaining ones. It happens automatically within 12 to 18 hours. It's like a built-in self-healing capability for the data.
So self-healing data, okay.
They also use anomaly detection and correction powered by machine learning. Services like Amazon Monitron constantly watch key metrics, CTR, CVR, for unusual deviations, specifically looking for changes of 2 standard deviations or more from the norm.
So it spots weird spikes or dips.
Right. And when it spots one, it can trigger data scrubbing, isolating potentially bad data, and replacing it using the redundant copies. Or it might trigger a ranking memory recalculation using clean backups. And remember that power law decay model. That also acts as a natural safeguard, because even if some tiny historical inaccuracies slip through, its influence diminishes over time anyway.
Makes sense. What about access? Who can touch this data?
Access control and auditability are incredibly strict. They operate on a zero-trust architecture. Basically, no one, not even internal folks, is trusted by default. Strict IAM policies, identity and access management, severely limit who can access or change sensitive ranking memory data. And AWS CloudTrail logs every single data modification, tagged with SHA-256 hashes for auditing. Plus, all data stored at rest is encrypted using AES-256 GCM encryption managed by AWS Key Management Service, KMS. And those encryption keys, they're rotated frequently every 90 days for extra security.
Zero trust, strict logs, encryption, pretty tight security.
Very tight. And there are operational safeguards too. Regular scheduled integrity scans weekly CRC64 NVMe checks using AWS Backup. If they find corrupted objects, they can restore them from Deep Archive backups in Glacier Deep Archive within 48 hours.
Okay, so they're constantly checking and have backups. What about deliberate cheating, like click fraud?
Fraud mitigation. That's crucial for protecting integrity from bad actors. The SLIDR system stands for Slice-Level Detection of Robots is key here.
SLIDR, okay.
It uses deep learning to analyze metrics, like CTR patterns, in real time, but it looks at specific segments or slices, like by device type or region or ad placement. This helps it spot invalid clicks or weird, potentially fraudulent patterns much faster. Things like CTR spikes greater than 300%. It can typically detect these within 48 hours.
300% CTR spike. Yeah, that seems suspicious.
Definitely. And when SLDR flags a suspicious campaign, the system can automatically reduce its bid weights, limiting the damage from the fraud. SLIDR also validates those external traffic sources we talked about, using things like reverse IP checks and bounce rate analysis to weed out anomalous impressions trying to game the ranking memory. The document also mentions built-in protections for smaller sellers so they don't get unfairly hammered, and penalties for stockouts are halved if the seller restocks quickly within 72 hours. This helps preserve that historical equity.
So they're actively fighting fraud in real time and trying to be fair about temporary issues. That level of protection, validation, automated healing, it all makes sense if you're building a system that has to trust past performance to predict the future.
It's absolutely essential for algorithmic trust.
So you have all these different types of data, behavioral, content, seller health, external traffic collected meticulously, managed by this incredibly complex, massive, highly defended infrastructure. And it all feeds into the system's memory.
Exactly. And the magic, maybe, is in how the ML models dynamically balance the influence of this deep 180-day historical memory with the immediate real-time signals happening right now.
Right, the balance.
Yeah. The historical data collected and protected like we discussed, provides the foundation, the resilience, that's the 180-day window, the evergreen status possibility, but the real-time signals a sudden inventory drop, a competitor launching a big sale, a spike in TikTok traffic linking to your product, how users are behaving this minute, that allows the algorithm to be agile, to respond instantly to what's happening in the market right now.
So it's not just looking back, it's looking around too.
Constantly.
Hmm.
And that waiting we talked about, it isn't static, it adjusts. Sometimes it favors recency more heavily, maybe during a huge shopping event like Black Friday, where immediate conversion is everything. Other times, it might prioritize consistency for those reliable evergreen products. And this balance point, the document notes, even differs by product category. The specific decay rates and metric weightings are tuned differently for electronics versus, say, groceries or apparel.
Fascinating. So it's like the system has this constantly evolving memory. It weighs both how reliable a product has been over time and how relevant and well-performing it is right now. That really explains how products can build momentum, but also why things like going out of stock can hit your rank relatively quickly.
That's a great summary of the dynamic interplay.
Yeah.
So just quickly bringing it all together, everything we've learned from the document about Amazon's data system for ranking memory. First, it collects this vast, incredibly granular range of data points way beyond simple ad clicks and sales. We're talking deep customer behavioral signals, content data from listings, seller health metrics, tracked external traffic, and a lot more. Second, while the raw data reports you can pull only go back a couple of months, 60 to 95 days, typically the algorithm itself retains the impact of that historical performance for much longer, up to 180 days. And this ranking memory uses that power law decay model, heavily weighting recent performance, with the last 30 days making up about 60% of the historical influence.
Got it.
Third, this is all managed by a truly massive, complex computational infrastructure. We're talking petabytes of data on distributed databases like DynamoDB and S3, processing trillions of real-time events daily, and running over 100 ML models using thousands of GPUs and specialized chips like Inferentia, all built on AWS services optimized for extreme scale and speed.
The engine itself.
Exactly. Fourth, data integrity is absolutely paramount. It's ensured through this multi-layered system. Sophisticated cryptographic checks, checksums, hashes, high redundancy across multiple physical locations, giving 11/9's durability, automated repair systems like erasure coding, ML-driven anomaly detection using tools like Amazon Monitron, super strict access controls with zero trust and IAM, encryption everywhere, and regular operational checks.
Protection and healing.
And finally, anomalies, weird patterns, and actual fraud attempts are actively detected and mitigated in real time. That's where AI systems like SLIDR come in, analyzing traffic patterns slice by slice to spot suspicious activity like those 300% CTR spikes within about 48 hours. And the system includes safeguards for smaller sellers and limits penalties for temporary issues, like stockouts resolved within 72 hours, to protect the integrity of that historical ranking memory.
So it's undeniable. Building this ranking memory isn't just about, having the numbers. It's about how that data is meticulously collected, stored at unbelievable scale, processed with incredible speed, fiercely protected for accuracy, and then constantly reevaluated by these complex models to build that dynamic, trustworthy picture of product performance over time. It really is the high-powered digital foundation underpinning so much of what you experience as a shopper or a seller on Amazon.
What really stands out, I think, is just the sheer technical sophistication and the scale that Amazon deploys purely to manage this historical performance data, all just to influence product visibility accurately.
Yeah, it really makes you think. In this world where we're just drowning in data, the true challenge, the real power, it isn't just in collecting everything. It's in engineering these systems that can reliably validate, structure, secure, and maybe most importantly, intelligently remember the right pieces of information to try and predict what happens next.
And that raises a really interesting question moving forward, doesn't it? As AI gets even more advanced, maybe starts pulling in even more subtle or, unconventional signals, how will that fundamental balance between the enduring influence of that long-term historical data and the immediate responsiveness to real-time shifts? How will that continue to evolve? And maybe more importantly, what does that ongoing shift mean for anyone trying to build long-term sustainable value on platforms like this?
That is definitely something worth mulling over. Thanks for joining us on this deep dive into Amazon's data engine. We really hope this look under the hood gives you a powerful new perspective on the invisible forces shaping visibility in the complex world of e-commerce.